Okay, so welcome everybody. Welcome to the first Mcule webinar. Thanks very much for attending. My name is Robert Kish. I'm the CSO of Mcule, and I'm going to be the presenter of this webinar. As all webinars, we are very much depending on the internet connection. So in case of any trouble, if you lose the connection, you can just reopen the browser and copy the link of this webinar. So try to go back in a new browser. Also, the webinar will be recorded. So again, in case of any trouble, you will be able to see the webinar again. We will upload the webinar to our YouTube channel, and you will be notified when this will become available. Right, so hopefully you can hear me, but unfortunately I can't hear you. And this is how this webinar thing works. But I encourage you to ask questions in writing on the left-hand side of your. There is a window for chatting, and if there is any technical issues, my colleagues will try to help you out. In case of any scientific questions, I will try to answer the questions at the end of the presentation. Yeah, so a few words about Mcule. Mcule is a very young company. We are a very motivated team, and the main objective of Mcule is to develop basically the best online integrated drug discovery platform. So that's the main goal of Mcule. And we are already after 1 year of development. So quite a few useful features and functionalities are already available, but we don't stop here. So a lot of things are going on, and a lot of new tools will be added to Mcule, a lot of drug discovery tools. So to achieve this goal, to become the best online integrated drug discovery platform, we utilize the latest state-of-the-art IT technology, and I hope you will realize that the IT technology behind Mcule is really great, and it helps to make your job easier to do drug discovery at Mcule.com. The main idea is about Mcule.com is that you don't need any IT infrastructure in-house. You don't need any IT maintenance, and you basically don't need to. You don't necessarily want to subscribe for certain software components for years to maintain annual software licenses. At Mcule.com, you can subscribe even for a month for a certain drug discovery tool, even for a single project. So that's basically that's the main goal. And yeah, I will just show you a brief outline of this webinar. So first, I will introduce a little bit the Mcule system, and I will show you a few case studies. Some typical drug discovery case studies, and how we can work on these problems at Mcule.com. And I will talk about the free and subscription packages that we are offering, and at the end I will be happy to answer any questions. Right. So this is basically how Mcule looks like, at least for us. So it's a very integrated system with many components. One of the main components is a reliable chemical database. So the Mcule database contains millions of purchasable compounds. And we have a very rigorous registration system, so we do a very high quality data curation. Our registration system has many tens of structure checks and normalization steps, so we basically filter out all problematic structures. We try to fix a lot of errors, but only in cases where we are pretty sure that we can fix the problem. If you're not sure about it, we label these structures as problematic, and we deal with them later, and we don't let these compounds enter into the Mcule database. So what remains in the Mcule database is just the non-problematic high-quality structures. So yeah, so in particular we do care about so we have a very good novelty check and valence checks. We check for unusual charges, isotopes, free radicals, a lot of stereochemical issues, untypical organometallic representations, and so on. So all these problematic structures are filtered out. And so all the compounds from the Mcule database are purchasable. So if you run any searches and screening on the Mcule database, and at the end if you have a hit list, then all these compounds are available for purchase. But we also we will also very soon allow to register your in-house chemical database if you have one. So you will be able to upload any structures basically, and all these structures will be integrated into the system, and they will be searchable and screenable in Mcule. The other thing we want to introduce is also the highly curated version of some external databases, like the NCI database, for example. It will be available very soon, and you can do some screening and searching on for example, on the NCI, the National Cancer Institute database. And so any searches or screening that is done on these databases so the results can be exported in various formats. So yeah, regarding the searches and screening, you can choose from different drug discovery tools. So some of these tools are for free and with some limitations. But if you're not happy with these limitations, or if you want some more, you can choose one of our subscription packages, which contains less limitations and more tools. The other important component of the whole system is that for evaluation, validation purposes, we also provide reference ligands. So soon we will introduce structures from the Campbell database, which at the moment contains about 10 million bioactivity data for a little bit more than 1 million structures. So these will be integrated, and these reference ligands can be used to validate and evaluate screening workflows, drug discovery screening workflows. So they will have to decide whether a certain screening workflow is able to distinguish between known actives, reference ligands, and inactives or decoy compounds. What we also provide target structures that have been prepared and they are ready for docking. So to do some structure-based drug design. Currently, the SCPDB database is integrated into Mcule that contains more than 10,000 X-ray structures that are readily available for docking. And so at the end, as I said before, the results can be exported, and you can take it and you can maybe post-process it in-house, but if the hits are from the Mcule database, we can deliver you the best compounds. Right. So I will show you some case studies at this point. So this is basically mcule.com, and if you are already a registered user, you can go to sign in and enter your username and password. But if you haven't got any account yet, you can click here, add your email address, and we will provide you in a few days or in a week the necessary registration data so that you can register and start using Mcule. If you are a chemical supplier, you can click here and contact us. If you want your compounds turned up in the Mcule database, just let's contact us, and we can discuss the details, and we can discuss what our criteria are. If you are a software vendor, you can click here, and if you have some tools you would like to integrate into Mcule, we are ready for any negotiation and discussion about this. Okay, so this time I will just log in with my into my account. Fortunately, I already have an Mcule username, so I'm just signing in, and here we go. So you might see that there are 3 different tabs here: search, screen, and collections. Under the search tab, at the moment we are under the search tab. So here you can do some very simple searches, like exact, substructure, and similarity searches. So this very simple user interface is for example, to check whether a particular compound is available for purchase. Is it part of the Mcule database or not? And so you can start drawing something, something like this maybe, and you might realize that there is no need for waiting for any Java applets to load. This is because this chemical, this catcher is a JavaScript molecular editor, and so it's already there. You don't have to wait for any applets to load. Okay, so you can start drawing particular compound, but if you have a SMILE string, for example, then you can paste the SMILE string here, and then click on Generate 2D, and here is the structure that you are looking for. You can also add, we can also paste in some inches and Mcule IDs at the moment. So this is the ligand we are looking for. The question is, can I buy this compound? Is there any chemical supplier who is selling this compound? And so the best way to check is to run an exact search on the search tab. So I'm just going to click on search, and the search has been started. And you might realize that now we are under the collections tab. So previously we were under the search tab, now we are under the collections tab. And this is because all your search results and hit lists, they are molecular collections. And all these are recorded and are kept safe. We save all of these. And if you click on the collections tab again, you see that, so these are all my previous search results. So these won't be lost, they will be always there. You can go back to these anytime. But of course you can also delete any of these collections if you like. So this at the top, this was our search, and this is our search result. So we indeed found this compound. It's available for purchase. It's part of the Mcule database. It has an Mcule ID. And now, so what you can do is, for example, you can ask for a quote by clicking here. Then you just need to fill out a small form, specify the amount you need, the minimum purity, delivery time, etc. And then you click on send, and we will try to we'll get back with the code for you for this compound. Okay. Other things you can do, you can export this compound by clicking on export, and you see that you can take this structure, for example, in an SDF file. You can click on generate file, and then you can download the structure. Yep. The other thing I wanted to show is that if you click on either the structure or on the ID, you will find yourself on the index page of that specific compound. So on the right-hand side, you see some identifiers, and at the bottom, you see that again you can take this structure as an SD file or SMICE or INCHI. You can download it. If you click on product availability, you can check whether this compound is available and which chemical suppliers are selling it. You might have seen that there was a little rolling wheel here, which is because at the time when I just clicked here on this tab, we checked automatically whether the compound is on stock of these specific chemical suppliers. In the first case, we wasn't able to retrieve any data, but in the second case, we know that it's definitely on stock, so you can order it right away. And as it is on stock, you probably it can be delivered in 2 weeks in the worst case. So if we go back. Okay, so we found this compound in the Mcule database. It is purchasable. It's fine. Now let's do another search. Let's see if there are more close analogs of this compound in the Mcule database. I don't want to just order this maybe a reference ligand, but I also want to check some close analogs. If you click on the load search button here, you can go back to your query, and this is true for all your search results. So we store your hit list collections, and we also store your queries, and they won't be lost. So you can get back to your query anytime, and this is very useful if you have, for example, very complex screening workflow that I'm going to show you in a minute. So you can always go back to your search query. And this is your search query. And now let's say that we want to run a similarity search with some reasonable Tanimoto similarity threshold. And we want to retrieve the top 100 most similar ligands. It's very important that the search won't start after just 100 ligands found in the database which fulfills this criteria. It will look for the 100 top most similar compounds. Okay, and I'm going to just click on search button, and now you'll see that the search is running, and in a few seconds we should be able to see the results. So now we are looking for similar compounds to our query. And the results should turn up in 1 or 2 seconds. Okay, so here they are. You see that the top compound is actually an exact match. So this was our query, and it is of course as well available for purchase. But we have some more very close analogs. We found some close analogs. Now I would like to show you that we have 3 different views. So the way you are looking at the data now is, so this view is called the list view. It contains the 2D representation of the ligand and some important screening parameters. So for example, the Tanimoto coefficient from the similarity search and a few identifiers. So this is the list view. If you click on the grid view, you will see the 2D representations only. And you see that, yeah, these structures are pretty similar to the query compounds. So our similarity algorithm did actually a good job. And what's really useful is this third view. It's called the table view, and this is indeed a table. And what's really cool about it is that you can add a lot of properties into this table, like molecular mass, number of atoms, log-p, PSA, number of rings, etc. And if you click on save, you see that all these properties appeared in this table. So now you can browse your hit, and simultaneously you can check a lot of other parameters if you are interested in the molecular mass, for example. And what's really exciting about it is that you can sort the results based on any of these properties, and this doesn't take any longer than just a fraction of a second in this case, because this is a very small library. But even for, let's say, 1 million structure, the sorting can be done just in a few seconds, and this makes Mcule very unique. So as I mentioned, we utilize really the state-of-the-art IT technology, and this is something you won't. So remember that we are on the web. This is not a desktop application. Even some desktop applications fail to, if they have to deal with thousands of structures and you want to do some sorting, for example. But this is on the web, and this is possible to be done in just a few seconds. Okay. Okay, so these were about very simple searches. Now let's do some real drug discovery, some more complex virtual screening. This is something we can do under the Screen tab. So if you click on the Screen tab, this part of Mcule is basically about building up virtual screening workflows. You can add as many filters as you like, and you can build linear virtual screening workflows. So let's assume that we are looking for a dopamine D3 receptor antagonist, and we want to set up a reasonable virtual screening workflow to identify some potential dopamine D3 antagonists. Okay, so probably, yeah, so at the top you see that the input collection is the Mcule database. So we are looking for good drug candidates in the Mcule database. And so probably it makes sense to start with a property filter. So yeah, it's probably useful to set up a boundary for rule of 5 valuations introduced by Chris Lipinski. You probably know that. It's some people call this drug likeness filtering, but it's actually not. But the rule of 5 rules are pretty good to at least to filter out some strange structures with very large molecular weight and log-p. So it makes sense to start with the rule of 5 filter. So we don't want any violations of the rule of 5. Then we can add, let's say, yeah, since the rule of 5 is an upper boundary, which is good to get rid of very big structures and very greasy structures, for example, we might also want to set a bottom boundary, because we don't really want to lose time on single benzene rings or something like that. So we don't want, let's say, any hits with the molecular weight under 150 gram per mole. Now we can, yeah, for the same reason, we can add that we want at least one ring in our among our in the structures of the virtual hits. And since we are looking for dopamine D3 receptor antagonist, it makes sense to set a property criterion for H bond donors. So you want at least one H bond donor in your compounds, because dopamine is a biogenic amine, and it's so basically any ligand that should bind to dopamine receptors, they should probably have one H bond donor functionality. This is because there is a crucial aspartate in all these receptors, and you want to have an interaction with this. Right. So now we have a property filter. It contains 4 criteria. Now we can go on and add another filter, which might be a smart query. You might be familiar with smarts, or might not. Smarts is actually very useful for defining complex substructure queries. If you want to learn more about smarts, you can go to doc.mcule.com, and we have a small description about our smarts filter. So we are going to use the smarts query filter for filtering out some unsuitable functional groups. So, for example, I will just copy a smart for nitro groups here. We don't really like nitro groups, and there are a lot of other functionalities that could be put here. Well, maybe some heteroatom bonds. Basically, the Rios filter of Mcule that we have developed, it contains more than 100 such smart rules with unsuitable functional groups. So these are typically reactive, and because of that, they appear in a lot of HTS assays as false positives. And since they are reactive, they are typically toxic because they just bind to anything, and it makes sense to get rid of these functionalities. Of course, there are exceptions, but since we have to deal with so many molecules and want to find the best candidates, one criterion might be to get rid of all the problematic function groups. Okay, so what we are going to do is so we added 2 smarts, and we don't want any of these smart queries above to match a structure. So if it matches a structure, then we want to exclude them. So we don't want these functionalities. So you can set these 2 things in smart filter. Now this is the appropriate setting. Okay, so let's go further and let's set a diversity selection filter next. So let's assume that we started with a few millions of compounds, and now we filtered out, let's say, 1 million, and all these compounds are going now through, or could go through a diversity selection filter. So we want to maybe focus on the 1,000 most diverse ligands of these. We want to prepare a diverse subset. I will just I've typed in 1,000. So in this case, we will retain the 1,000 most diverse ligands after this step. So before the diverse selection, we might have 1 million compounds. After the diverse selection, we only have the most diverse 1,000 compounds. Right, and we might add another filter, docking, for example. We utilize the VINA algorithm, which we had quite good experiences with previously. We had to we performed 2 real drug discovery projects, and at the end we experimentally validated our hits. These are structure-based, docking-based studies, and we had quite nice hit rates. So VINA is a very good docking algorithm. Okay, so what we can do is we can select a target from the almost 10,000 prepared target structure. Okay, so we are looking for the dopamine D3 receptor. So we just type in dopamine, and you see that this structure turns up. It's actually a GPCR structure, a G protein coupled receptor, and this crystal structure was sold, I think, last year. So it's a quite new structure. If you click on View in 3D, you can take a look at the protein. It's actually, so this part of Mcule is under development. At the moment, you can zoom in and zoom out and take a look at the protein. This is actually the D3 receptor. But we are developing this further, and you should be able to select the binding site later on, display side chains and backbones. But remember that we are on the web, and you can take a look at the protein, and you can rotate it quite fast. And this is something you probably weren't able to do ever on the web before. And this is thanks to the WebGL technology that we are using. Okay, so this is just to show you that you should be able to deal with your protein later on. At the moment, you can take a look at the protein. Okay, so I'm just going to close this, and I'm going to select this crystal structure for the docking. And you might see that all these parameters, the center of the binding site has been populated. So this is automatically defined based on the coordinates of the co-crystallized ligand. So this is an automated approach. The protein is prepared automatically, but if you have your own protein, you can also upload it by clicking here, and you can decide whether you want a preparation or not. You can also prepare your protein in-house and upload it, and then you can use it for docking. You can upload structures in PDB, MOR2, or PDB-QT formats. Okay, I will just add one more filter. This is called the sampler filter, and this is actually very useful. What it does is actually, so before the sampler filter, there might be 1 million compounds, but after the sampler filter, there will only remain the top 1,000 compounds. So it will sample the chemical space before the sampler filter, and you can, if you place it in the middle, so for example here, before the diversity selection, you can reduce the size of the molecules that are going to the next step. So I'm sorry, I will just set this to 100. These numbers are quite important at this point, because so everything what you have seen, it's part of the free package, but the free package has some limitations. So these green boxes show you how many input ligands can go through a particular filter each month. So you have these boundaries, but if you want some more, just contact us, and you can obviously subscribe to one of our packages, and then these boundaries will be go away, basically. So for example, for the docking, you are allowed to dock 500 ligands each month. This is of course just for demo purposes, but if you set a screening workflow very accurately, you might be able to get some reasonable results even with these boundaries. But if you need some more, just contact us. And So for example, I will talk about this later, but our docking package will include 1 million compounds per month. So if you subscribe for a docking package, you should be able to dock 1 million compound each month. Right. Okay, so we have a virtual screening workflow that should identify a few dopamine D3 receptor antagonist candidates. All right. So I'm going to execute the screening workflow now by clicking on screen. And the screen is running now. You see, this is a more complex screening, so it takes a while to see the first results. But in 1 or 2 minutes, you should be able to see some of the results already. If you realize that you did something wrong, you can abort. Click on abort, and the screening will be aborted. And so if you realize that you set some parameters wrong and you want to abort the screen, you can do it. And in most of the cases, then you won't waste your molecules in the docking and the diversity selection filter. So you won't use any monthly molecules that are allowed. So you can spare some of those by just aborting such screens. So this is the point where usually you can typically you can grab a coffee. But the good thing about Mcule is that you can continue working. So it's not like you are on the web, so you are not allowed to do anything because you don't want to waste your results, or you are afraid that all the results will disappear. So if I'm just closing this window now and I'm opening a new one and go back to Mcule. And if I'm going back to collections, you see that the job is still running, so you don't need to worry about it. Your results are on the way. You cannot do anything wrong. And you can click on anywhere else. You can also click on screen and you can do some more screening. So basically you can execute another screen. You can build up another workflow. So for example, we can go to search and look for this compound in the Mcule database, do some searching. Yeah, and if I click in that to the collections tab again, you see that this very simple search has been finished. So we indeed found this compound, but this more complex screening is still running. But we already have some results. So if I'm clicking on here, some of the ligands have already docked, some of the molecules have already docked into the dopamine D3 receptors and went through all the filters. And now we are done. So I will just switch to table view. And okay, so this is a weird structure here, but yeah, this compound looks reasonable. And so this is basically the best candidate for the dopamine D3 receptor. Of course, we only docked a few compounds, so if you want to get some more reasonable results, then you might want to extend this workflow and screen more molecules, dock more molecules. But after docking just a few, this is the best candidate, basically. And if you click on this compound, you will see that there is a view in 3D button here. If you click on that, you are able to see the binding conformation of the ligand. Of course, this is not that useful without the binding site. What we are working on this, and very, very soon you will be able to see the binding site together with your docked ligand. At the moment, it's just a docked conformation of the ligand, but there will be more very, very soon. Okay, so as before, this compound can be both, if you like. The results can be exported, so all the results can be export it by clicking here, or you can order all hits basically by clicking on quotes. But if you, so for example, you want to just browse the results, you know, this is an ugly compound, you don't really want to order this, but this is nice. Wow. Okay, this is not that bad. And for example, this one. So let's assume that you want to buy these three compounds only. Then you have selected these three, and you can click on Add to. We will just create a new collection. Here I will just type webinar test collection. Yeah, it's going to be the third one. And you can also choose whether this collection should be private or public. By default, it's always private. And you can create any molecular collection anytime, and you can set this whether it should be private or public. Now it's going to be a private collection. You can also add some description if you like. Now I'm going to click on Save and going to click on OK. And this will add these three compounds into this new collection. And if we click on the Collections tab, you see that this new collection is already there. And indeed, it contains these three compounds. Now you can go and order only these three compounds if you like. Okay, so yeah, so you might realize that this is a pretty integrated system. So you can build screening workflows, very complex screening workflows in just a few minutes. If you have information, you can utilize this, and you can basically also run the screening very easily and very quickly. So what's really cool about this technology is that you don't need to integrate all these tools, so you don't need to convert the output of one tool to be a suitable input for another tool. We do this behind the scenes. You just put together the filter. You might want to evaluate the screening with some reference ligands, and if it gives some good results, then you can go on and do the screening. And at the end, you can export the results or order the compounds as well. So this is basically it. So this was the these were the case studies. So I'm just going to continue with the slideshow. And oops, yeah, we are already here. Okay, so as I said, we have a free package. So all registered users will get immediate access to the free package, which contains access to the Mcule database. You can do some molecular collection management. You can do exact, similarity, substructure searches, property filtering, docking, diversity selection, smarts, filtering, etc. And also you can order the compounds. And all the compounds you order, they will be delivered as a single package. So it doesn't matter how many chemical suppliers are selling those compounds. You don't have to deal with these. This is actually a very painful part of the whole process. And so we want you to focus on the science rather. You don't need to care about the compound procurement. We negotiate with the vendors, so we do that part. What you get is a single package with your virtual hits, and we do care about all the delivery, customs clearance, etc. Okay. But the free package also has some limitations, as I mentioned. If you're not happy with these limitations, then you can contact us or subscribe to one of our subscription packages. So regarding the subscription packages, what's really important, and it's really great, that you can subscribe for 1, 3, 6, and 12 months for a certain tool. So this is quite unusual, and we have been negotiated with some software vendors about this for a long time. But and this is definitely a very new model, but hopefully it will be a very useful model for you. So you don't need to maintain in any case annual licenses. You can subscribe for just 1 month for the tool you want, and these packages will be introduced during the next few weeks and months. So you can basically hire a tool for just a single project. All right, so let's just go through the packages. We have an Mcule database access package, which contains, so what you get access to is the Mcule database containing all supplier information, supplier names, IDs, availability, price data, quality data, quality control, purity, and you can download the whole database if you like, or a subset, including all these data. This is basically what it is about. The library design package, it contains everything what's included in the Mcule database access. So you get all these data, plus you get a REOS filter. REOS is for rapid elimination of SWIR that I was talking about before. It helps to remove all the unsuitable functional groups. And you also get unlimited diversity selection and unlimited smart query filter. And you also get access to some higher level tools, such as GPCR likeness or kinase likeness. So you can build focus libraries by using our experimentally validated screening workflows, for example, for the GPCRs. You can just, so imagine a filter that is called GPCR likeness, and then you can, if you put that filter into your workflow, then the resulting compounds will be probably active on GPCR, so they have a larger likelihood to act on GPCRs. We also will introduce a docking package, and as I said, it will contain 1 million compounds to dock, so a 1 million compound limit for the docking filter. But it will also contain some other useful tools for selecting decoys. Decoy compounds are putative inactives, but if you are familiar with the structure-based drug design thing, it's actually not an easy thing to find good decoys that have physical chemical properties that are similar to your reference ligands, and this is where this tool helps you. The other tool is pharmacophore optimizer, and it can be put after a docking filter. It will, so you can define a lot of criteria, distance criteria primarily. So for example, if you want to have an H bond with a certain part of the protein, or you just want to have an H bond anywhere between the ligand and the protein, so these are the things you can set in this pharmacophore optimizer feature that will be part of the docking package. Okay, we are also integrating tools from our partner companies. So, for example, Chemaxon. It's widely known about its tools, so the Marvin suite and the calculator and the physical chemical calculator plugins. They are probably the best. According to my opinion, it's probably the calculator plugins are probably the best physical chemical property calculators that are available at the moment. So Chemaxon is very good in this part. And so we have integrated the calculator plugins, which means that you can get access to more than 100 pre-calculated physical chemical properties, Chemaxon properties, for the Mcule database, so for each molecular in the Mcule database. And you can use these properties for filtering. So log-P, log-D, pK, charges, etc. And in this case, so these properties are calculated by default parameters. But if you want to calculate these properties by using some custom parameters, so for example, you want to calculate some charges at pH 4 or pH 5 and not at pH 7.4. Then you can subscribe for a property access and calculator package, which will also allow you to calculate these properties with any kind of parameters if you like. BioSolve GmbH is our other strategic partner company, and they are very famous because of the FlexX docking tool and the F3's ligand-based drug discovery tool. These are very good brands of BioSolve IT, and we will introduce an F3's visual similarities package, which will get access to feature trees. Feature trees or F3's, it's a fuzzy similarity searching tool, and it's very suitable for scaffold hopping. So, and what's really unique about it, that it actually visualizes the similarity between the query and the hit compound. So we'll see why two compounds are actually similar. It's very useful, and we had some very good experiences with F3's. We published a few papers about it. So it's a very useful ligand-based drug discovery tool, and it will be also introduced you in the next few weeks or 1 month. Right, so we have all these packages, and all these functionalities can be accessed at the mcule.com website. But if you're looking for something special, you need a customized solution, you have special needs, or you have to follow some specific business rules, then we can provide you with a solution on a consultancy basis. In the case of a consultancy work that we can do for you, we of course guarantee full confidentiality, and we can do several things. So for example, we can extend your in-house library with some very diverse new ligands that are purchasable basically from the Mcule database. We can also do some modeling support for drug discovery projects. We can provide you with valuable chemical starting points for early phase of starting drug discovery projects. But there's one tool that could be particularly useful, especially for pharma companies, and it's called the Idea Validator. And I'm going to show you this in a minute. So let me just sign out, and just give me a second. Okay, so here it is. I had to change users because this is not available by default in your account. So Idea Validator, the basic concept behind Idea Validator is that medicinal chemists can have a lot of ideas. You know, they can come up with a lot of structures, and they don't know whether it's going to work or not. They might have some intuition. They expect that it's going to work, but it would be actually very useful to prioritize all these ideas. So if they have 10 ideas, let's first focus on the best one and synthesize the best one first. And this is where the Idea Validator can help you. So if you start, drawing something let's say, this compound. So this is their idea, or an idea of a medicinal chemist. He can draw in the idea, and he can select a project or a target he's working on, and he can click on test. So the question is this a good idea? Is this going to be a good candidate for inhibiting the histamine H4 receptor or not? And this is what they get. So they get the score, and they get a green or red colored box. This helps to make go, no-go decisions. This helps to prioritize the ideas. And this can be very useful if it's working very smoothly and quickly. And this can spare a lot of time for medicinal chemists as well as for computational chemists, actually. So medicinal chemists may go to the computational chemists to validate some ideas, but they can use this very simple interface for a pre-filter to really focus on the best ideas. This concept can be actually extended by several other things. So we can also show some toxicity alerts. If the compound has a high probability to be toxic, then we can also show an alert here that look out, this might be toxic. You don't really want to synthesize this compound. You should focus on something else. The other thing that can be extend this idea is to give alerts for physical chemical properties that are out of the drug-like area, if you like. So, for example, if the ligand has a large molecular weight, or it's too greasy, it has a calculated log P of 10 or something like that, then in that case as well, you can show an alert. This very much fits into the ligand efficiency and other such parameter theory. It helps in lead optimization and in the heat to lead process to keep the molecular weight low and keep the log P low as well, because otherwise if these parameters go up, you will end up with unsuitable ADMET parameters. Okay, so basically what's behind this very simple interface, it can be a lot of screening workflows, for example, a lot of calculations, and the calculations can be set together with the computational chemistry group of the company. We certainly have some suggestions, but this is something we can discuss with the computational chemistry group together. Right, so this was the idea validator, and just going back to the slides, and I basically only have, I only have one last slide. Yeah, this is it. So this was basically it from me. Thanks very much for your interest in Mcule and attending this webinar. I hope it was useful for you. And if you would like to learn more about Mcule, just please contact us. And actually, in the middle of August, we'll fly to the States. So if you would like to meet us, if you want a live demo or something, just contact us and we can meet up. Also, we will attend the ACS conference and we will have 9 presentations. So hopefully, I will see you, or we will see you, or some of you at the ACS or somewhere else. Okay, so thank you very much. And if you have any questions, I will be happy to answer your questions. I will just go to the chat area and check if there is any question. Okay. Yeah, so is in-house database a part of Mcule database? By default, it's not. But as I said, we will allow upload your own structures. So if you have an in-house database, you can upload the structures, and so it will become part of the system. I mean, it will remain private for you. No one else will be able to see it. But you can also conduct all the searches and all the screening, so everything just like on the Mcule database moleculars. Do you query on public chemical database like Zinc or PubChem? No, we don't. If you have any specific chemical database you would like to search and screen, as I said, as soon as the user upload will go live, you can do it. But I don't suggest to upload the whole PubChem database, for example. But if you have a subset you would like to screen or search, you can do this. Probably the way it's going to work, you will be recommended to do at least an automated curation based on our registration system to filter out a lot of problematic structures, because believe me, there are a lot of problematic structures, and we know that there are a lot of issues in these databases you mentioned. So it's probably makes sense to do a data curation first, and you can upload this, so you can upload the structure, do a data curation. You should be able to do this in Mcule soon, and do some searching on these databases. Are free tools are available for industries? Yes. So everything what you have seen, what is part of the free package, it's freely available for everyone. So if you are from an industry, you can use everything that's included in the free package. So for the subscription packages, we have different prices for industrial and academic users. So we distinguish between the two. But yeah, so I already answered the question. So the free package is available for everybody. Okay. So what happens if I don't find the compound in Mcule database? Well, that probably means that it's not part of the Mcule database, which means that it's not available for purchase, at least through Mcule. So you might want to try to procure to look for it in some other databases, but it's very likely that you won't find it at anybody else. So actually there are a few things you can do. So you can do a similarity search to find some close analogs that might be available. If the exact structure is not, there might be it's possible that some close analogs will be available. And we have been thinking about to start something else, but at the moment I can't really talk about this, but we will have a solution for this. Basically, so we are in connection with a lot of chemical suppliers, and if they are happy to synthesize that compound, then we might offer you that this compound can synthesize the compound for you, even if it wasn't available before in stock. Okay, how do I order? So compound ordering, as I've shown, it's available for all molecular collections or single moleculars. You should look for so you should look for this quote button here, the orange quote button, and what it does is actually so you are asking for a quote you send this information to us, and we will get back to you with a quotation. Okay, so what is the docking algorithm? It's VINA. The docking algorithm we have integrated so far, but we are planning to integrate other docking tools as well. But at the moment, what you can get access to is VINA. It's a very good docking tool. It's a pretty new one, very fast, and it gives quite reliable results, I would say. I've checked. I've been working with a lot of other docking tools. I don't want to give you a list of them, but I've spent a few time in the drug discovery industry, so I've tried a few docking tools, and at the moment I would say that the best results I achieved so far was with VINA. So it's actually developed that scripts by Oleg Trot, and yeah, again, we had quite good experiences with VINA so far. So what does the underlying engine of ID Validator do? What metric is being used to give the score? Yeah, so this tool, the ID Validator, it can be developed on a consultancy basis. So you have seen a value, but that was a made-up value, so there was no meaning at all. What we can do is to set up screening workflows that works behind this. So a lot of calculations can be put behind the ID Validator, and this is something we typically try to set together with the computational chemistry group of our pharma company. So we have our suggestions for that. We can do a lot of things, but so for example, we can dock the ligand into certain X-ray structures, and we can also do some similarity searching by using reference compounds. What's behind can be also trained, so you have more and more in-house data in the project. We can automatically train the model behind the ID Validator actually. So this is something we can do. Okay. Okay. Yeah, I maybe wasn't clear about the docking part, so we are using VINA, but you might want to hear something more specific about this algorithm. It's actually a genetic algorithm that finds suitable poses, and it has a stochastic global optimization of the scoring function. It pre-calculates grid maps for the protein, and well, I can send you the actual paper that was published in the Journal of Chemical Information and Modeling about the algorithm. It's a quite good and reliable docking tool. All right. So it looks like so I reached the end of the questions. If you have any more questions, feel free to ask. I will just wait for a few more seconds or a minute. Yeah, and in the meantime, feel free to do any testing on the website. We are happy to hear any feedback. This is very important for us to develop the things any further. We have a lot of plans to improve, of course, but if you have some suggestions, feel free to drop us an email, and we can prioritize all the ideas. And if you very much want something to appear in Mcule, or if you have a certain tool you are very familiar and you want to have that tool in Mcule, you want to use it, then let us know what the tool is. If it's commercial, we will contact the software vendor, and so we try to negotiate and try to integrate the software for you and for everybody else, of course. Okay, dokie. So if there is no other question, if there is any, or if you don't you can't come up with another question now, but if you have some more later, again, contact us, just write us an email, and we will get back to you with an answer. Okay, so thank you very much again for joining this webinar. I hope you find it useful. Yeah, so have a nice day in the US and have a good night for any European or on the Asian attendees. Thank you very much again. Bye-bye.